Welcome to AI4Cloud's Business Impact tutorial. AI4Cloud brings the benefits of artificial intelligence to enterprise infrastructure management. Today we're going to show you how AI4Cloud's Business Impact facility provides real-time impact analysis and business risk assessment for medium and large enterprises. AI4Cloud's offering is based on an industry-leading technology that leverages a type of narrow artificial intelligence. It analyzes conditions of interrelated infrastructure elements in near real time to provide sophisticated root cause analytics across applications, virtualization, servers, network devices, and storage devices as well. Our solution does this via a semantics-rich, extended common information model that is unsurpassed in its level of embedded human intelligence specific to IT infrastructure behavior. This human intelligence for how infrastructure elements behave, what kind of common service affecting problems they can have, and how these problems propagate to their neighbor elements is embedded in each object represented in the model. As the solution dynamically adjusts to the monitored infrastructure, it constantly relearns these element relationships, adjusting to each customer's unique environment to understand and identify the root causes of common infrastructure problems and their impacts on other elements and their risk ultimately to the business service. Our built-in intelligence supports the latest IT infrastructure technologies and ties them together into a single seamless real-time picture of infrastructure health. We support a broad array of infrastructure elements from many of the major vendors. We use industry-standard interfaces such as SNMP, WSMan, including vendor-specific or open APIs to gather real-time data from the underlying infrastructure. Our solution understands resilient relationships such as clustering, clustered applications, or clustered servers like Microsoft or VMware, as well as network, server, or even storage virtualization and redundancy technologies. Our solution tracks the status and relationships of these underlying elements, understands their behaviors in terms of common service affecting problems within and between these elements, and provides a root cause determination for customers. The solution also identifies when redundant components are degraded or at risk, preventing outages in the first place. We provide our enterprise infrastructure monitoring solution as a cloud-based service. Our customers subscribe to our service either via VPN or, in some cases, via direct private connection to AI4Cloud. We then connect to the customer's network via that VPN or direct connection to discover, analyze, and monitor that infrastructure using our enterprise class toolset and standard secure protocols. We provide the back-end administration using our expert administrators. The customer receives up-to-the-minute reports, alerts, and root cause messaging from an enterprise class solution without the headaches of actually having to maintain it. Our business impact management solution is a set of objects with embedded semantics or behaviors, embedded meaning in those objects, that they understand what a department is, what a service offering is, and how that service offering is composed of a set of services, and how those services might be composed of or dependent on underlying infrastructure elements. Well, from a simple perspective, you have customers that subscribe to services that are part of service offerings that are dependent on and composed of a variety of application elements that are dependent on the underlying infrastructure of network, servers, disk arrays, load balancers, and the like in terms of infrastructure topology. Well, that's a simplistic perspective, but we all know that with today's expanding network technologies, not only do we have the physical storage layer and the physical networking layer, and what we have traditionally known as a logical networking topology layer of VLANs, IP addresses, basic routing technologies, load balancing, etc., but overlaid over that physical infrastructure and logical networking infrastructure are virtual networking topologies like virtualized network functions, firewalls, load balancers, intrusion detection devices, and other types of virtualized networking functions. And all of this underlying infrastructure, at the end of the day, subtends the physical compute layer that comprises all of the virtualized compute layer that supports the application topology that ultimately supports the business functions. AI4Cloud Solution ties all of these infrastructure elements together into a single holistic data model with semantics embedded for the behaviors for these objects, the relationships between them, and the status that these objects might have, and how the status of these particular objects affects their neighbors, and ultimately how that bubbles up to affect the business topology. Discovering everything in the infrastructure except the business layer is an automated process. As you'll see in the demonstration, tying business functions to the underlying discovered infrastructure is a fairly easy and straightforward process. A major advantage of our business impact solution is that the only manual activity required is to stitch the business topology to the application service layer. The automated intelligence in our solution identifies which underlying components support that application service. It automatically assesses the health and status of the related underpinned elements to provide both an accurate root cause determination and a real-time risk and impact assessment to the business service. The health of the application service is the cornerstone used to determine business risk and business impact, providing root cause analytics, identifying where the actual problem is, where the symptoms are, and which business services or business departments and functions are affected by that particular at-risk condition or outage. It does this all in real time and provides those analytics. And we'll talk a little bit about that. We're going to talk about how Business Impact Manager works, how to construct business impact management objects, how to connect them to the underlying infrastructure. This is a simple example of modeling a business process. In this map diagram, we present a simple outline of a radiology department that depends on multiple applications and underlying infrastructure elements. The department, represented here by the org chart icon, subscribes to the service offering shown here as a contract. The radio imaging service is composed of the business processes of image acquisition, supported by redundant servers, radio imaging processing, which in this case is provided by a third party, so there's no underlying infrastructure to track in this particular case, client image retention, and image transfers that depend on specific IP resources. These business processes are dependent one on the other from a business process point of view, but they're also dependent on underlying application-specific services delivered by the underlying infrastructure. For example, these redundant servers that provide image acquisition, or say a web-based image catalog service, or even a set of IP elements specific to secure image transfers. All of the underlying infrastructure is discovered, modeled, and analyzed automatically and is maintained in near real time, with the topology staying in sync with the dynamic infrastructure changes, including changes like vMotion and cluster relationships. In the demonstration, we'll show how simple and easy it is to connect the business topology to the underlying infrastructure. It's primarily a matter of connecting business objects directly to high-level application services. The software automatically understands the underlying infrastructure relationships and dependencies required to support the application service. In the next and final screenshot, we'll see a basic example of how this business logic works to help an organization prioritize infrastructure conditions. In this example, we're viewing the real-time Java console. It's a very mature interface, which has resulted in it being extremely flexible and quite feature-rich in terms of operations functions. It is accompanied by a contemporary HTML5 based interface that includes maps and alerting, but also includes in-depth historical reporting, trending, and analysis. The HTML5 interface will be the topic of another tutorial in this series. If we look at our alert screen, we can see that it automatically prioritizes the events by impact to the business. If we open the Web Service Redundancy Group alert, we can see what business elements are impacted by this at-risk condition. In this case, the Web Server Redundancy Group being at risk by having only one remaining service available left in the redundancy group has a potential impact on the service offering radio imaging and also the department radiology, but also the dependent business processes, in this case image acquisition, radio imaging, and image retention, all as a result of the Isilon catalog being at risk from reduced redundancy. We also were checking for TCP connectivity required to service the image catalog. Although it could have been unavailable for a variety of reasons, say a hung process, out of memory or CPU condition, or a problem with the underlying ESX or Hyper-V server, or even a network issue nearby, the root cause has actually been determined to be the actual TCP port, the HTTP service itself. This allows the right party to begin addressing the problem immediately. Please join us in the next session where we demonstrate how to easily map your business processes to take advantage of our business impact feature for infrastructure management. This is an example of a simple hospital example in this case. It's composed of a radiology department. Here you see sort of a department icon. It looks like somewhat like an org chart. And that department radiology subscribes to a service offering of radio imaging. And the service offering of radio imaging is composed of the image acquisition phase, right? Radio imaging department itself, image retention, and then image transfers that might be moved between various elements across an IP network. So this business process, right, is dependent on underlying infrastructure elements. The image acquisition piece is dependent on a redundant set of servers that provide the image acquisition facilities. In this case, we just tied it to a couple of servers as an example, but to provide that understanding of what redundancy, of how we can create redundancy groups and provide at-risk conditions to that image acquisition business process. And the image acquisition process feeds radio imaging that feeds image retention, and that feeds image transfers. So these are a set of dependent processes. They're dependent one on the other from a business process point of view, but they're also dependent on underlying infrastructure elements, whether it's a set of redundant servers or a particular service offered up from, say, a Isilon storage infrastructure, or an IP network service that provides image transfers to a particular another department or facility. So the underlying infrastructure is easily tied to the business impact elements, such that no matter where the problem occurs in the underlying infrastructure, if it affects the particular object that the business process element is dependent on,